Do you remember what a ratio is? Well, it's a way to look at two different numbers. For example, 4 out of 5 dentists recommend a certain toothpaste. We're comparing the numbers 4 and 5. And we do that in trigonometry too. But what we usually do is look at triangles and compare the lengths of two different sides. And this is an introduction to the primary trigonometric ratios. So the three ratios we use have names. Let's bring up our calculator. You might have seen these three buttons on your calculator: sine, cos, and tan. Those are names given to three ratios that look at the lengths of the sides of a triangle. So let's see those ratios with an example problem, and I'll get you to try one on this side a bit later. We've been given a right angle triangle that looks something like this. And we've been given the task to write the trigonometric ratios for sine A, cos A, and tan A. Now if you notice, we use the letter A here 3 times: sine A, cos A, and tan A. So what it's asking us to do is picture ourselves pretty much standing right here in this corner of the triangle at angle A. And we'll have a look at some ratios. We'll compare the lengths of sides. For example, the length of this side versus the length of this side, and so on. But before we can build any ratios with our triangle, we need to figure out what's called the opposite side, the adjacent side, and the hypotenuse side. Probably the easiest one of these to do first is the hypotenuse. The hypotenuse is always opposite to the right angle. In other words, you can picture the right top corner of this red square facing this side, and that'll be our hypotenuse. So I've just gone ahead and labeled side AB as the hypotenuse. Okay, now for the opposite side. The opposite is always the line that's not touching the angle, or the corner. So for example, if I look at this corner, two lines meet here: line AC and line AB. So that just leaves CB. It's not touching that corner. So that's the opposite side to angle A. So finally, line AC, the last one there, must be the adjacent side. If you've just read step 2 and you don't know what the heck is going on right here, don't worry about it. That's an acronym, and we pronounce it SOHCAHTOA. And what it stands for is sine is a ratio equal to opposite over hypotenuse, cos is adjacent over hypotenuse, and tangent, well, that's opposite over adjacent. And we're going to use that right now. Let's do the first one. So, sine is opposite over hypotenuse. I'm going to say sine A is equal to opposite over hypotenuse. Well, let's go back to the triangle that we labeled in step 1. Opposite is right here, CB, and it's 12 centimeters. So I'm going to put down a 12 over H, or hypotenuse. Well, the H, or hypotenuse, is right here, line AB, and it's 15 centimeters. So I'll write down a 15. All right, so let's move on to the second part, the ka part. Cos is adjacent over hypotenuse. And maybe now you can start to see the pattern here. I'm going to say cos A is equal to, adjacent is 9 centimeters, so I'll say 9 over hypotenuse, which again is 15. And then we come to the TOA part of SOHCAHTOA. Tan is opposite over adjacent. Tan A is equal to, opposite is 12, and adjacent is 9. These are our three trigonometric ratios for this triangle. Now we're almost done. If we want full marks though, we have to remember that any ratio must be expressed in lowest terms. So to do that, I look at my first ratio and I figure out what's the largest number that divides into both of these numbers. And it looks like it'll be 3. 3 goes into 12, and that's going to leave a 4. And 3 goes into 15, and that's going to leave a 5. And that's as far as I can go with that. For cos A, looks like the same number is going to go into both of these, 3. So 9 divided by 3, that's 3. And then 15 divided by 3, well, we already saw that, that's 5. And finally, for tan A, would you believe it, the same number goes into both of these numbers. So 12 divided by 3, that's 4, and then 9 divided by 3, that's just 3. And these are our 3 primary trigonometric ratios for the right angle triangle we've seen up there. So when you're first learning how to use sine, cos, and tan, try and remember this acronym, SOHCAHTOA. It's very helpful. Sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. Okay, let's get you to try a practice problem over here. Let's get you to write the trigonometric ratios for sine A, cos A, and tan A for the following triangle. And here it is. Okay, so try that one out on paper and I'll post the solution when you're ready. So your answers are sine A is equal to 3 over 5, cos A is equal to 4 over 5, and tan A is equal to 3 over 4.